very pleasant afternoon, everyone. I'm V.V.S.N. Sainidhi, and I'm doing my master's from Sri Padmavati Mahila Viswavidyalayam in the stream of Electronics and Communication Engineering. So I'm here to present my paper in the title of Turbo Codes for Efficient VER and Capacity for Massive MIMO Systems in the International Conference of Robotics, Communication Technology, Electrical and Electronics Engineering. So I've done this work in the esteemed guidance of Mrs. K. Prashanti ma'am, head of the department for ECE, Sri Padmavati Mahila Viswavidyalayam, Tirupati. So moving on, we have the contents. I'm going to discuss about the abstract, introduction, technical aspects involved in the system, working block model, advantages of the proposed system, outcomes achieved, conclusion, and references. For the brief gist of what the concept is about, I'm going to tell you on how we are going to use a turbo encoding methods to enhance the bit error rate and the capacity of a massive MIMO system. Moving on to the brief introduction, what are these massive MIMO systems? I hope every one of you are aware of the 5G technology that is being so famous these days. And it is a well-known fact that the 6G technology is also having its research going on. And I'm going to focus on the 5G technology, otherwise called the massive MIMO technology. So here is a table that you can see on the different communication technologies and generations we have. And I'm going to focus on the last one, which is the 5G technology. Let me just give you a few advantages of this upcoming technology. Basically, the need of this 5G technology is we're going to enhance the speed of internet. We're going to enhance the advanced versions of LTE and other communication modes. And then there are some technical aspects involved in the system, such as the turbo encoding, which is the heart of the whole project, the antenna subset selection, channel state information, CCDF, capacity versus SNR plot, and BER plot. So here is a working block model. I'm going to give you a brief explanation for each of the block. The message source, we're going to give an input of around 1,60,000 bits for the message, and then we are going to encode it. Encoding is nothing but a process that we're going to change the common language or common message into a binary message. So here, as I already told you, we are using the turbo encoding system, which is also, in short, a classification of the convolution encoder. The convolutional encoder we are using here is punctured convolutional encoder, or otherwise called the concatenated convolutional encoder. So what we are doing here is we are going to make a turbo encoder by combining or cascading a few convolutional encoders. Basically, telling you the advantage of a turbo encoder, we can say that these encoding technique will help us to reduce the latency of the system and to improve the capacity of the system, to reduce the BER, that is the bit error rate of the system, and finally it is going to result in an efficient output. So, and then we have the BPSK modulation here, and the information will, the modulated information is then going to pass through the channel propagation, and we're going to estimate a few parameters over there. The parameters that we are going to estimate is nothing but the BER and capacity, and then we are going to demodulate our signal, and then we are going to see a few outputs also. This is the explanation I've already given. And now let me just give you advantages of this proposed system. As I've already told you, this is going to reduce the latency, which is in common terms called the delay. And then we have the power consumption. Also, we are going to, just utilize less power as possible, because this massive MIMO technology, it is going to use n number of antennas at the transmitter and receiver ends. And as you all know, this is all costly and expensive technology. But in this case, we are going to reduce the cost effectively, because we are not going through the traditional communication models, which include the RF chains, which are also called the radio frequency chains. So we're not including all this complicated technology in the system, which is further going to make this more cost efficient and also simple. Next, here I'm providing a table. This table particularly is a comparison between the reference paper I have taken for the research and also the dissertation work I have done. So in the reference paper, they have given for the LDPC encoding, and in my paper, we have taken the turbo encoding for the encoding purpose. We're using BPSK modulation and the same in both the papers, and now the the calculation is being done for approximately 1,60,000 bits as the input message, and we are going to use 8 transmitting antennas and 16 receiving antennas. Here is the major output that we are getting from the project. On the left, you can see the LDPC encoded data, for which we are getting a BER of approximately 0.001 at a SNR, that is the signal to noise ratio of 13 dB. On the right, you have the dissertation work that I have done using the convolutional encoding, that is the concatenated convolutional encoding, which is going to result as the turbo encoding. And we are getting approximately 0.00001 a BER at only 4 dB signal to noise ratio, which is a far effective value. Next, we have the capacity comparisons for both the papers. On the left, you have the capacity for signal capacity for LDPC encoded data. On the right, you can see the signal capacity for turbo encoded data. The basic capacity algorithm that I have used here is the ergodic capacity, and we can also have other capacity calculating algorithms such as water filling algorithm and etc. So even the capacity also, you can see that we are getting a reasonable and effective capacity. Moving on, these are a few statistics that I have already explained. This is another additional plot, a CCDF plot, the cumulative distribution plot that we have used for the power characterization and how the power is going to stay for a how the probability of the power to be above a reference level is going to show from this CCDF plot. And for the conclusion, such kind of technologies are having a lot of scope these days, and there are also many other scopes that we can bring out of this. As I have used the turbo encoding method, some other person can use other effective encoding methods, such as the Reed-Solomon method or the Raptor codes, and we can extend this further research in terms of modulation techniques and many other aspects that are involved in a communication system. Here are a few references that I have got for the technical aspects and other programming thing. The whole project has been done in MATLAB version R 2020A. And thank you all for your precious time. I'd like to thank the organizing committee of IRAJ and the conference. Thank you all for this opportunity.
Thank you, Sainidhi, for your wonderful presentation.